Hey everyone, welcome to Lecture 9. So today, I'm just going to start off with some announcements, and then we're going to look at some common mistakes that I'm seeing students make in the labs and homeworks, and we're going to go over some of the homework 2 answers and some of the harder problems. So I know some students had a hard time with sum of digits. Part of that was the way I described it, that was my fault, but I do want to show some interesting concepts in that problem. And then I'm also at the end going to go over the restaurant bill problem. That was the bonus problem for Lab 2, just to show why it's important to name variables the way you do and how to keep your code organized. Because the challenge with the restaurant bill problem was just keeping track of all the different variables and all the different steps. So before we get into that, let's start off with some announcements. So it seems like students aren't really checking out the EdStem. So stuff like when I send the announcement and it sends you all emails, like I'm seeing maybe like less than half the class is actually looking at these announcements. So if you're not getting the EdStem emails to your Morehouse email, please let me know. Generally when I make an announcement, you should get an email, and I want you to click on the link and open it and see the announcement in EdStem so that you can see all the information. So for example, Wednesday's lecture is going to be virtual. If you don't check the EdStem, you might not know that, and you might be wondering where everyone is at on the Wednesday lecture. So again, you don't have to come into class on Wednesday, September 7th. Just please make sure you watch this video in its entirety before the next Friday lecture. Note that Wednesday lab will still be in person. And this lab is going to be a different kind of lab than we've done before. This lab will require you to get TA approval or professor approval before you move on to the next parts. So really make sure that you come to lab either today, Friday at 4 p.m. or Monday at 5 p.m. And again, you can see all this information in the calendar. So I have here, like, there's office hours with Trey on Tuesday, office hours with David on Thursday, office hours with me, typically Monday, Wednesday, Friday. And then the labs, again, you can come into multiple labs just so you can use it as a working session and finish your homework and get questions answered. Okay, so let's get into the actual material. The first thing I want to recap is variable assignment in multiple ways, because I think students are still kind of struggling with this concept. So the first way that we learned to do variable assignment was you define the variable. So to define the variable, you say what the data type is, and you say what the variable name is. This is so that the computer knows when it creates the variable in memory, how much space to assign it. So if you create a variable of type int, then it knows to set aside 4 bytes of memory to store whatever information you want in there. To actually store information and assign that information, we use what's called an assignment statement. So we put the variable on the left side, in this case player. We use the assignment operator, which is a single equal sign. I saw in Lab 3, students were going back and forth. If you put 2 equal signs, that's the equality operator. That's to check if 2 things are equal to each other. If you only put 1 equal sign, that's an assignment statement, where whatever value is on the right side of the statement gets assigned to the variable that's on the left. So now anywhere else in the code after this, whenever we call player, it's going to be equal to jaw. One thing I want to emphasize with this, we've always kind of just done string literals on the right, but you can do any combination of stuff. So if we had int num1 is equal to 5, int num2 is equal to 7, we could do something like int num3 is equal to num1 plus num2. So we can do some sort of expression on the right side. It doesn't have to just always be like a numeric literal like this. You can do variable addition or subtraction or multiplication, whatever you want, on the right hand side. So if we're to visualize this, remember you can either define the variable on one line and assign it on the next, or you can combine them in 2 like we did here. So after line 6 runs, the value 7, which is on the right side, is going to be assigned to num2. So this is going to change to 7. And now at this part, we see what the value is, because the right side will evaluate first. We check what the value is for num1, and it's equal to 5. We check the value for num2, it's equal to 7. So 5 plus 7 is equal to 12, and 12 is going to be assigned to the variable num3. Hopefully that makes sense. So again, if you do it that way, using the equals operator, the assignment operator, that's called the assignment statement, and one way to assign a value to a variable. The second way you can assign a value to a variable is by getting user input. So again, we define the variable before we actually use it, so string player. We ask the user what is the player's name, and then we use the cin special keyword and these stream operators, the two greater than symbols, to assign the value into player. So they each have their purposes. If you already know the value or you're doing some sort of mathematical operation, then you'll use the assignment statement with the equal sign. Otherwise, if you're just trying to get input from the user, then you use these two greater than symbols. We'll be doing this for the rest of your career in coding using these two methods, so really make sure it's clear. And if you have any questions, please let me know in office hours or by email. Okay. One other related issue I'm seeing with this is the order of the code matters a lot. So if you had this code and then later you said num1 is equal to 5, num2 is equal to 7, or I see this also when people are getting inputs, they do like the cin line later in the code. What's going to happen here? Visualizer's taking some time due to massive traffic. Alright, I guess a lot of people are using the visualizer. We can kind of step through it ourselves though. So we define the variable num1 and we define the variable num2. So they both have a spot in memory, but they don't actually have any values assigned to it. So it's kind of just this question mark. It has some random value, like there's something there because we've created a spot for it in memory, but we don't know what is actually stored there. And so at line 7, when we try to do num1 plus num2, a lot of students think like, oh, num1 is equal to 5 because on line 9 we set it to 5. But at line 7, the code doesn't know that. At line 7, it can only use whatever information is above line 7. And above line 7, we have not assigned any value to num1 or to num2. So num1 is random, num2 is random, and so when we step here, num3 is also going to be some random value. And so that's actually, if we're to print out at the end, we can see that it's probably going to come out to some like crazy random number that we're not expecting. Again, while it's loading, just try to think about what's going to happen. So num3 here, num1 is random, num2 is random because we haven't assigned any values before we use it. So num3 is also going to be random. Now we set num1 equal to 5. Now we set num2 equal to 7. But num3 doesn't change because there's no more assignment operator for num3. So if we print out num3, this one is just saying like it's an error, it's an uninitialized value. If you were to run this in EdStem, it would just print out some random value. So again, the ordering of the code matters so much. You can only use what's available when the code runs at a given line. Cool. So for homework 2, I put in examples of buggy code, and I had you explain what the error is and how you would fix it. If you haven't done this homework 2 problem yet, please do it first before you watch this video. Again, I'm just grading on effort, right? So it's fine if you didn't get the right answers, but these are the kinds of problems that you're going to see on your exam. So if you have not done this problem yet, do it first so you can get exam practice, and then come and watch the video to see how many you got correct, because that'll let you know what areas you need to practice on before the midterm coming up in a few weeks. Okay, so this first problem, we'll put it in the scratch pad. Let me zoom in a little bit. Okay, so what's happening here? We define the variable num apples, and then we have 5 is equal to num apples. So what happens? So we have the assignment operator. So the user's trying to do some sort of assignment. The way the assignment operator works is whatever value is on the right side gets assigned to the variable that's on the left side. So again, if we look at this slide, it should be whatever is on the right will get stored in the variable that's on the left. So in this example, it looks like it's kind of reversed. We're trying to store whatever's in num apples to the numeric value 5, which doesn't make sense because 5 isn't a memory spot. So if we wanted to fix this, we actually have to switch the order. So it should actually be num apples, the variable on the left side, is equal to the value 5. And so now if we run this and we print out num apples, we get 5. So 5 equals num apples was the wrong line. The order is switched. All right, let's try the second one. So we define a variable of type int, and we call it weight. And on line 6, the order is correct, so we have this numerical literal on the right side, and we store it in the value in the variable weight. But when we run this, oops, see how num, so I guess there are actually 2 errors in here. I meant to print out weight. So num apples was undefined because we didn't define it in this. But if we were trying to print out weight, we see that we just get 140, even though we assigned the value 140.5. And the reason being, weight is an int variable, which means it can't store decimal values. So the 0.5 is just getting eliminated, and just the value 140 is being stored, and that's what we print out. So if we wanted to fix this, we should switch this to a double, and then run it again, and now we get the full value, 140.5. Okay, so that was the error I intended. The other error was we used this variable called num apples without actually defining it. This should have been weight. Okay. Number 3, let's put it in the editor. Okay, so we ask the user how many songs are in the album. We try to store that in a variable called num songs, and then we try to print it out. But if we run it, it says num songs was not declared in scope. So at line 6, it's saying it doesn't know what num songs is. And that's because when we're doing cin, the variable has to already be defined earlier. So we have to actually define the variable num songs before we use it, and here we just use the variable name. So you can't define a variable and put input in the same line. They have to be 2 separate lines. So if we run this, looks like maybe there is one more error that I perhaps did not intend for. Oops. Okay, let's try running it again. No match for operator. Okay, so 2 errors here. See if you can figure out this one as well. The order the arrows matters for cout and cin. So for cout, it's 2 less than symbols, kind of like a mouth that's speaking to the world. Cin is 2 greater than symbols, because the data is getting funneled into num songs. So now if we're to run it, how many songs are in the album? 7. There's 7 songs in the album, because num songs is equal to whatever the user typed in. Cool. So again, 2 errors in this one. When storing a value using cin, the variable has to be defined before, and then also the arrows have to be pointing the right way. Number 4. Hello. Okay. So string name, and we want to print out hello, and we would expect it to say hello Steve, because we have the user's name Steve stored. So why is it just printing hello and not hello Steve? This is again, as we talked about earlier in the video, the ordering of the code matters a lot. At line 6, it tries to see what the value of name is, and in this case, we haven't assigned it to anything. So it could have printed out some random characters or a random number. In this case, it just didn't print out anything. And so if we wanted to print out the right thing, we have to move this variable assignment earlier in the code. Before we actually use the variable name, we want to assign it. And so now if we run it, we'll get hello Steve. All right, the final one we have here, getting the sum of 3 numbers. So of course, if we wanted to get the sum, we could just do sum is equal to num1 plus num2 plus num3. But this is another way of doing it, where we keep updating the sum variable. But in this one, we get some super crazy big number, 32,693. So what's going on? We define the variables num1, num2, num3, and sum. So they all have a space in memory, but they don't have values yet. On lines 7 to 9, that's where we assign values for num1, num2, and num3. At line 11, we have sum on both sides of the equal sign, but the right side will always evaluate first. So what's the value of num1? That's going to be equal to 5. What's the value of sum here? We haven't given a value to sum yet. So it just takes some random value and adds 5 to it, and then stores that random value here. So what we really want is we want sum to initially be equal to 0. Now it'll give us, let's take a step. So sum is 0 plus num1 is 5. So sum after this line is going to be equal to 5. Let's actually see this in the visualizer. I think it'll be easier to actually visualize it. And think about what this code is going to do while we're waiting for the visualizer. So many people are trying to use this program today. Okay. So after this first line, we now put the value 0 in sum. And then each of these next 3 lines are just going to assign the values. So 5 to num1, 4 to num2, 6 to num3. And so now at line 11, remember the right side evaluates first. So the value of sum is 0, and the value of num1 is 5. So 0 plus 5 is 5, and that gets stored in sum. So if you note, right now sum is 0, but after this line, it's going to change to 5. Now, at line 12, what's the value of sum? It's 5, plus num2 is 4. 5 plus 4 is 9. So the value in sum is going to update to 9. Now sum here, right side goes first. Sum is 9. Num3 is 6. So 9 plus 6 is going to be equal to 15, and that's going to be stored in sum. And so if we print it out, we get that the sum is 15. Now our code works. So we just had to make sure we initialize sum equal to 0 at the start. Cool. So that's all for the debugging stuff. Again, we'll have very similar problems on the exam. So if you feel like you're still not getting it, let me know and I can try to create more practice problems like this. Cool. So I'm going to go through 2 more problems. The next one I'm going to go through is the sum of digits problem. Because I know part of it was I didn't super clearly lay out the algorithm. So if you're to try it now, I've more clearly laid out the steps. With problems like this, what I'm seeing though is students are starting to jump straight into the code without really understanding what's going on in the problem. So especially for these more complicated problems, I would highly encourage you to just take some examples. So take any 3-digit number, and before you start coding, just walk through the steps and make sure you understand what's actually going on. Because once you understand that, then it will be easier to write the code. So let's step through it. So what we're trying to do is we have a number like 423, and we want to sum the 3 digits together. So if we were to do this without thinking about code, how do we do it? We would take maybe the rightmost digit, 3, then we would add 2 to it to get 5, then we would add 4 to it to get 9. But the question is, how do you break up this number into these individual digits using code? And to do that, we can use the modulus operator. So first, let's just follow the steps here. So create a variable to store the total. So let's create a variable called int total, and we'll assign it the value 0 to start. This is going to be ultimately the sum of the numbers, the total. All right, so what happens if we do a number? We will be asking the user for input, but it's also easier when we first code it to just do a value that we know will always be the same, just so we can see what's happening. So we can do like int number is equal to 423, just for this example, but later I'll put a note to myself, change to get user input later. Okay. So one thing that helps is to just print out what is going on. So if we were to print out 423 modulo 10, just to see what happens. If we did 423 divided by 10, so we'll do both of them. So we would expect 423 divided by 10 to be equal to 42.3. But because it's int division, the decimal gets dropped, and so we're just left with 42 with a remainder of 3. So we would expect the first line to be equal to 3, that's our remainder, and we would expect the second line to be 42. What you'll notice is this 3 is the rightmost digit. And that's what, when we were walking through the example, we said we're first going to add the value 3, then we're going to add the value 2, then we're going to add the value 4. So this 3 kind of gives us the first step. And then dividing it by 10 gives us a smaller number. So instead of it being 423, now we're working with the number 42. And so now let's think about how to put this into the code. So step 2 and 3 is get the rightmost digit. So that's going to be number modulo 10. So as we saw, that gave us 3, which is the rightmost digit. And we want to add that to the total. So we take our existing total, which at this point is just 0, and we add this rightmost digit. And whatever that is, so in this case 3, that will get stored in total. Now we want to make the number a little bit smaller. Step 4. We want it, now that we've used the 3 in the sum, we don't care about that last digit anymore, so we don't want to keep it. So we want to update number to now just be equal to 42 instead of 423. And so the way we can do that is we take that existing number and we can divide it by 10. So again, it helps to see what's happening in the code, so let's print out what the total is at this point. And then let's also print out what the new number is. So total is equal to 3, and the new number is now 42. Great, and so that's what we had matching for steps 3 and 4. So now we can continue with the algorithm, step 5 and 6. So now we're just dealing with the number 42. And so again, we can do the exact same line. So it's going to be total plus number modulo 10. But remember, the first time we did this, number was equal to 423. Now, because we divided number by 10, and we assigned it to number is now just 42 right here. We had this printed out. So number is 42. 42 modulo 10 is going to be 4.2. So it's essentially 4 with a remainder of 2. So this is just going to be 2. And that gives us, as we see here, 42 modulo 10 is equal to 2. And we add that to the total, which at this point we saw total was 3. So it's going to be 3 plus 2 is equal to 5. And so we'll print out here total. So let's just run it before we do anything else. The benefit of running and printing each time is that now if there is an error here, we would know it's only because of this. If we wrote all the code at first and then ran it, then the error could be anywhere. But by doing this incrementally, we're able to pinpoint where errors might arise. Awesome, so the new total is 5, which matches our step 6. And so now for step 7, we now again want to make numbers smaller. So right now number was 42. Now we want to make it even smaller just to be left with the last digit. And we can do again the same step. So remember, the order of the code matters. Even though we're doing the same step as line 14, we're dealing with different numbers. In this one, number was equal to 423, and we were dividing that by 10 and storing that in the new number, 42. So now we're really doing 42 divided by 10. We're not doing 423 divided by 10. Really, it's tough for me to explain it over a video. Really try to like absorb this and play around with it and do cout statements to try to understand what's going on. And if you still have questions, come into my office hours and I can try to explain it more clearly. But just to show, we'll call it like new number second time, and we'll print out number just to make sure. So like, now we did 42 divided by 10, and so now the new number is equal to 4. And so the last step now is add the leftmost digit to the total, so we're just left with 4, and so now we can just add to the total. So it's the existing total we had before, plus that last digit, which is 4. And so if we print out final total, and we'll print out total. And final total is 9. So we started with 3, we added 2 to get 5, we added 4 to get 9. So note that even though we used the same variable total multiple times, it kept changing values. So this is a pretty hard problem. Again, if you got stuck on it, I'd encourage you to try it. Even after seeing this video, try it again by yourself. So, you can watch this video, do it once, get it marked, get the points, but then try doing the problem again by yourself to make sure that you really understand it. So even if you've gotten credit and you've done it, try doing it this way where you just use 2 variables. You have total that keeps getting updated over the course of the program, and then you have number, which again keeps getting updated over the course of the program. And of course, in this case, we hard-coded it with 423, but when you do this for your homework, make sure you do cin and you get the user input. Okay. The final problem I wanted to go over was the bonus problem, the meal cost. So again, if you haven't done it, I'd encourage you to try it. It's a good problem just to see how code can get more complex. The biggest issue I saw when looking at students' code was that the variable namings were a little bit unclear. So choosing good variable names is super important because it makes the code more readable and it helps you understand what's going on. One thing I'm seeing when students are naming variables, so again, we can't put spaces in the variables, which means that when we name them, we have to do something that's called lower camel case. So let me pull up the slides for that. We covered it at the end of lecture 4. The main reason why we use lower camel case is that it makes the code easier to read. So if you had like a long variable name, it might take a while for the user to read it. But if you do it like this, where the first word is all lowercase, and then every word after that starts with a capital letter. This is how you should be naming your variables. So let's put that into practice. Generally, when we're working with anything related to money and user inputs, we'll be using doubles. So for this one, let's see what we want. One is going to be the tax in dollars. One will be the tip percent that we're going to be getting from the user. And then one is going to be tip in dollars. Like we want to convert everything to dollars. And the final thing is meal cost. So let's start with getting the meal cost from the user. So let's see what the program is asking. Cout. What was the base cost of your meal? And we'll do cin to get it. And we'll store that in meal cost. And maybe we'll call it base meal cost, just to be super clear. Okay. And then we also want to ask the user, what percent do you want to tip? And we'll store that in tip percent. Great. So let's do the first step. So the first step is to calculate the tax in dollars. So tax in dollars is equal to the tax percent, which is 4%, So we'll do 0.04 times whatever the base meal cost was. So remember, when we're doing variable assignment, the right side will evaluate first, and it can be an expression. So if we wanted, we could have stored 0.04 in a variable. It's also okay to just use it directly and multiply it by the variable base meal cost. And again, as we talked about in the previous program, it's good just to verify that the code is doing what we want. So let's run this now. What was the base cost? We'll do a value like 100. The tip percent doesn't matter now, so we'll just do 25. And we see 0.04 times 100 for the base meal cost is $4. So the tax is $4. We can add in another variable that's called meal cost after tax. Okay, so we don't need the cout statement anymore. And the meal cost after tax is equal to the tax in dollars plus the base meal cost, right? So now if someone were to read my code, they would see, okay, this is the meal after tax. So it's essentially taking whatever the tax in dollars was and it's adding it to the base meal. And so it's easy to understand what value this variable is storing. This helps us because in step 3, we want to know what the tip in dollars is. So step 3, this one was step 1 and 2, calculate cost of meal after tax. Step 3, calculate the tip in dollars. So let's say the user wants to tip 25%. That 25% doesn't get applied to the base meal cost, it gets applied to the cost after tax. That way the waiters can get more money because the cost after tax will be more expensive, and so when you apply the percentage to that, the tip will be larger. And so to do that, the user is giving us a value as a percent, but we need to convert it to a decimal. So we can do tip percent divided by 100. That way we get it in decimal form, kind of like how we had 4% got converted to 0.04. And then we want to multiply that by the cost after tax. And so this is easy for me to know where that is because I called the variable meal cost after tax. So it's very easy. I don't really even have to think. I just see, okay, multiply by the cost after tax. That's what I have stored here. And we'll store whatever the result of this is in a variable called tip in dollars. And so again, let's print out tip in dollars just to make sure it's working. So we run it, and we'll use this example. So we'll do 100, and then 20% for the tip, and then we expect the tip to come out to $20.8 based on this example output. And 20.8, we got it. So everything's still going well. And now we can do the final step. Step 4, calculate total cost. Okay, so total cost, again, we can create a variable here. Total cost is equal to tip in dollars plus, or we'll do it in the order here. So we'll do cost after tax plus tip in dollars to get the total. Again, note that the order matters. If we were to move this total cost line to line 16 before we've calculated tip in dollars, we're going to get a random value. So we have to make sure tip in dollars has a value, which it does based on line 18, and we have to make sure meal cost after tax has a value, which we know it does after line 15. Okay. And then we can print out the total cost. And so in this example, we would expect it to be 124.8 based on the example, and we get that. And so now the final part of the code will be formatting this in the desired format. Cool. So just showing the code overall. Note that the code actually isn't that long. I know some people had like a lot of lines of code and it got a little bit confusing. Really, if you really think about what the code is doing and you choose good variable names and you use this lower camel case where the first word is lowercase and then every word after that starts with a capital letter, it makes the code much clearer and much easier to understand. So again, if you have any questions, you're always welcome to come into my office hours or the office hours of Trey at 1:30 to 2:30 on Tuesday or 2:30 to 3:30 on Thursday with David. We're always happy to help. I have noticed some of the assignments, like homework 2 submissions, are lower. Not everyone has completed it. Please make sure you complete it, otherwise you'll fall behind. And as we've talked about in computer science, the concepts build on each other. So if you don't do homework 2, it's going to be very hard to do homework 3. Again, sorry I couldn't be with you all in class today. I'll let you know how the Wheel of Fortune game show filming goes. Hopefully if I solve at least one puzzle, we can do a mini watch party when it airs later this semester. And I'll make sure to give you all a shout out when they do my introduction. Sweet. Again, come into lab Wednesday if you're in that lab section from 5 to 6. Otherwise, I'll see you all on Friday.